Welcome dear students to this lecture. I hope you have watched the first lecture and understood what is similarity and also the three properties and formulas of ratio of areas of triangles. If you have not watched the first video, please watch it as it will make you understand the chapter better. I have put the link of this video in the description. Children, if you like my video, please subscribe my channel and share the link with your classmates. In this video, we are going to understand how to solve activity given in the textbook on page number 3. There are 3 activities which is in the form of a fill in the blanks. Remember, activities are not only very important from the point of view of exam because it comes in the exam in the form of fill in the blanks, but is also important in understanding the concepts and of course the entire chapter. So let us start doing the activity given on page number 3. So let's do the first activity. Here you have a figure ABC triangle and you have to find the proportion of ABC upon APQ. Now before we try to fill it, we'll try to understand the figure. So in this figure, first thing is we have taken ABC. So we will draw the figure ABC separately. So here you have ABC. So ABC. Okay, ABC is the first triangle. And the next triangle is APQ. APQ. Okay, here you have ABC, the bigger one. Okay, and then you have APQ, the inner one, inside one. Okay, now what is the base of ABC? We'll look at this figure. ABC, the base is BC. So base is BC, and here you have the height. The height is AR. We have height here AR. And in triangle APQ, base is PQ and height is AR. Again, base is PQ and height is AR. Now what is the common thing here? The height is the same. So we'll use a formula base into height. So the formula number 1, what we learned, triangle 1, area of triangle 1 upon area of triangle 2 is equal to base 1 into height 1 upon base 2 into height 2. So what is base 1 now? What is base 1? This is base 1. Okay, base of the first triangle. This is the first triangle. This is the second triangle. Okay, here this is the first triangle and this is the second triangle. Okay. You can look at the neat figure or you can look at my drawing. So here we have, what is the base? Base 1. The base 1 is BC. So we will write here BC into height 1. What is height 1? Height is the height of ABC, which is AR. So we will write here AR upon B2 into H2. B2 means height of the second triangle. Base of the second triangle. Base of the second triangle is PQ. So B2 is base of the second triangle. So which is, we will write it as PQ. Into height. What is the height of the second triangle? The height of the second triangle is AR. We will write it as AR. Now AR and AR is common. So this will get cancelled. And finally we will get BC upon PQ. So if you have tried the fill in the blanks, area of triangle ABC upon area of triangle APQ is equal to this part. We'll take this part first. BC into AR. Okay, then below part, that is the denominator will be PQ into again AR. Since AR is getting cancelled, the final answer will be, this is the final answer, which is BC upon PQ. So we will see once again the answer. So what is the answer? Area of triangle ABC upon area of triangle APQ is equal to BC into AR upon PQ into AR. Why did we get BC into AR? That is B1 into H1. Base is BC, height is AR, and upon B2 into H2. Base is PQ and height is AR again. So this is getting cancelled and we are getting BC upon PQ. So final answer, what will be the answer? BC into AR upon PQ into AR, and the answer will be BC into PQ. See, I am doing it 2-3 times so that you'll understand it properly, and the second time I show it so that it is done neatly, because with my diagram, the drawings, the screen will look little untidy. So that is why I made a separate figure, a separate page with the writing very neatly. So if you want, you can write it down also. Now let's take the second activity. Here a triangle is given, that is LMN and DMN. LMN is here, the bigger one, and the DMN is a smaller one. We have to find, there are 4 blanks. This is dash into dash upon dash into dash is equal to dash upon dash upon dash. Now let's try to find out. This is finding the ratio. So we'll take the diagram separately. Here we have triangle LMN. So triangle LMN, LMN. What is the base? Base is MN. So this is B1. And height, the height is a line joining from here. The height is LP. Here you have LP. Now the next triangle, which is a smaller triangle, inside the bigger triangle, here you have it here, and I have drawn it here also. That is DMN. DMN. And what is the height? The height is DQ. So base is, this is B2 and this is height. So what is the formula? A1 upon A2 is equal to B1 into H1 upon B2 into H2. So what is B1? B1 is here, that is MN. Base is MN into height. What's the height? LP. It's here. LP is here. Okay, and in this figure, it's here, the bigger height. Into LP upon, what is base 2? Which is base of the second triangle, which is, the triangle is DMN. So the base is MN again. Okay, the base is MN of DMN. This is the triangle DMN and the base is MN again. You can see in this the diagram which is given in the textbook, the big triangle, and this base is common for both the triangles. So MN into, what is the height? That is height 2, which is DQ, or DQ here and DQ here. So you have DQ. Now what happens? MN and MN gets cancelled. So the final answer will be LP upon DQ. So what is the question? Area of triangle, this should be area. Area of triangle LMN upon area of triangle DMN equal to, what did we get here? MN, that is base 1 MN into height 1, which is LP, upon base 2, which is MN again, into height 2, which is DQ. And since MN gets cancelled, the answer will be LP upon DQ. So here once again we'll have a look. So here you have triangle LMN, base is B1, which is MN, height is LP. In triangle DMN, base is, that is base B2 is MN again, H2 is DQ. What is the formula? A1 upon A2 is equal to B1 into H1 upon B2 into H2. So area of triangle, this should be area of triangle area of triangle LMN equal to Mn upon Mn into LP upon Mn into dq. Then Mn gets cancelled. So therefore the final answer will be area of triangle DMN, area of triangle LMN upon area of triangle DMN is equal to LP upon dq. Now, in order to do the next activity, we need to understand some terms. That is the third activity. The first thing we need to understand is midpoint. What is midpoint? Midpoint is a middle point. This point divides a segment into two equal halves. So, if you have a segment and you have a point in the middle, as it will be known as a midpoint. What is the speciality? It divides the segment into two equal halves. Now here you have a segment AB. The total length of the segment is 6 and the M is exactly the center. So AM will be 3 and MB will also be 3. So M is the midpoint, hence AM is equal to MB. So remember, whenever there is a midpoint, that means it divides the segment into two equal halves. The next term we need to understand is median. Median is a line segment that joins a vertex and the midpoint of the opposite side of a triangle. So median is, first of all, it's a line segment. Okay. It joins the vertex. What is a vertex? Vertex, we learned, is the corners of the triangle and the midpoint of the opposite side. Midpoint means, as you learn, midpoint means middle of the segment. Which segment? Opposite side. So opposite side of the triangle. Now here you have a vertex. So line segment joining the vertex. So here you have a vertex B. As we know, vertex is the corners A, B and C. So we are taking this vertex B. Now this is the line which is joining the opposite side. Which is the opposite side just directly across. So the line segment which is joining the opposite side with the midpoint. So D is the midpoint. Now this line segment is known as a median. So what is a median? Median is a line segment that joins the vertex and the midpoint of the opposite side of a triangle. So let's take another corner or another vertex. Now in this case we are taking C, the other corner of the triangle ABC, and this line PC is the median. Why? Because this C is joining with P is the midpoint of that segment AB. That means PB is equal to AP. So remember, median is a line segment joining the vertex and the midpoint of the opposite side. The third example, you have vertex A, you have the opposite side BC, and you have this is the median which is joining this midpoint M. So I hope you have understood what is median. Median is a line segment that joins a vertex and the midpoint of the opposite side of a triangle. Let's take the next activity, which is the third activity. In the figure, M is the midpoint of seg AB. That's a question. M is the midpoint of seg AB. CM is the median of triangle ABC, and area triangle AMC upon triangle CMB, area of triangle AMC upon area of triangle CMB is equal to dash upon dash, which is equal to dash upon dash, which is equal to dash. This is the question. So let's try to understand what is given in the question. The first is CM is the median and CM, this part, is a median. Median means from the vertex to the opposite side, midpoint of the opposite side. Now CM is the median. Now C is a common vertex of both the triangles. I'll draw the triangle separately afterwards. So I'll just show you in the figure. C is a common vertex, that is in both the triangles, that is AMC and CMB. The common vertex is C. C is a corner which is common in both the triangles AMC and CMB. And since C is common for both the triangles, and these 3 points are collinear. What is collinear? Collinear means in the straight line. Since these 3 points are collinear, therefore the distance of C from these points is the same, since they are in the straight line. Okay, so the condition is that since the vertex is from that collinear line, the distance is the same, therefore the height is the same. So you have to remember this. Whenever the point is, there's a common vertex with a base which is collinear, with the points which are collinear, then we can say that the height is the same. So in both the triangles, the height is the same. So we'll take the figure separately. So here you have triangle AMC. So AMC, C, A and M. Okay, so we'll take the height here as H. And then we have the second triangle, that is CMB. Again, C is there. And slide. This is an obtuse angle. CMB. Remember, the height of an obtuse angle, actually it comes outside, not inside. Okay. So here you have the height, which is again this H, or this H here. So what is the base? Base is AM. And here it is MB. So let's take the formula. Base is, before we write the formula, let's write the base. Base is MB of this triangle. And the other triangle, it is base is AM. First triangle, this is the first triangle and this is the second triangle. Okay. First triangle, the base is AM. The second triangle, the base is MB. This is the second triangle. Height of the first triangle. As I said, height is the same for both the triangles. Why the height same? Because vertex to the opposite sides, there is a common vertex for all the triangles. Therefore, the height is the same. So here also the height is H, and here also the height is H. The height is H. So when we take the formula, what we have? Height is common, right? So we will write A1 upon A2. Since height is common, we will write, which is the formula we'll take? B1 upon B2. Height is common, so we don't have to take the height. So what is the base here now? Base is MB. First triangle base is AM. Which triangle are we taking first? AMC. AMC, the base is AM. Okay. Second triangle, we are taking this triangle, the obtuse angle triangle. What is an obtuse angle triangle? Triangle which is more than 90 degree. So here the base is MB. I'll show you once again, but just explaining with a rough diagram. Now here you have AM upon MB, which is base 1 upon base 2. Okay, we have learned that formula. When the heights are equal, then we will write B1 upon B2. Now remember, B1 is AM and B2 is MB. M is the median. Not M, sorry. CM is the median and M is the midpoint. What is the meaning of midpoint? Midpoint is when it divides the part into two equal halves. That means AM is equal to MB. Right? AM is equal to MB. If this entire thing in the previous example I showed you, that entire thing is, suppose it is 6, then AM will be 6, 3 and MB will also be 3. Okay, so AM is equal to MB. So you can write AM upon AM. Instead of writing AM upon MB, we can write AM upon AM, because AM and MB is the same, right? So what do we write? We write AM upon AM. Now what happens? AM upon AM, AM 1s are AM, AM 1s are AM, that is 1, 1. 1, 1 upon 1 is 1. Okay, let's understand with a neat figure and a neat writing. Now here you have M is the midpoint of seg AB CM is the median of triangle ABC, area of triangle AMC upon area of triangle CMB. This should be area. Okay. Now here you have in triangle AMC, we have taken the diagram AMC here. Base is AM. This is B1. Height is, we have taken it as H. Next triangle CMB, base is MB. And height will be outside here. This will be H. Now since heights are the same of both the triangles, therefore which formula will take? A1 upon A2 is equal to B1 upon B2. Now what is B1? B1 is base of first triangle, that is AM. We have written AM here. And what is B2? B2 is the base of the second triangle, which is MB. We have written MB here. Now AM is equal to MB because M is the midpoint of seg AB. Why is M the midpoint? It's given M is the midpoint, and not only that, seg CM is the median of the triangle. When we have median, that means it is connecting with the midpoint. Therefore, instead of writing AM upon MB, we can write AM upon AM. So AM cancel it off, it will be equal to 1. So what is the reason you will say? The reason is areas of two triangles having equal bases and equal heights are equal. Okay, so areas of two triangles. What is the base is also equal and the height is also equal. Therefore, these two triangles are equal. I hope you have understood the activities which we have solved in this video. I also hope that you are sitting with a book and pen and writing it down. Children, please practice whatever you see in the video. Only if you practice that you will be able to remember. Only watching a video will not help you at all. You have to write it down and practice. In the next lecture, we will understand the first solved example which is given in page 3. Now remember, I am doing only one sum or maybe two sums in a video. So if you can do more than that at a time, you can skip or go to the next video. But in a video, I mostly try to solve one or two sums only, so that you are thorough with it and you understand it properly. Okay, and again practice your sums, and only then you will be able to remember it. And once your concepts are very clear, you will not find it difficult at all. Okay, thank you very much, and God bless you, dear children.